Good morning all, welcome to lesson 7 of theme 3 GCSE Geography. We're going to continue with the theme of tectonic hazards and we're moving on from earthquakes to looking at tsunamis. So we're going to annotate a series of diagrams to explain the causes. We'll then use a case study. We're going to use the Asian tsunami, also known as the Indian Ocean tsunami or the Boxing Day tsunami. We're going to use that as a case study to look at the impacts and effects of a tsunami, and then identify ways in which areas can reduce their vulnerability to the impacts of tsunamis. So pause the video here a moment, write down the title, and we'll get started. Okay, so if we just remind ourselves of what a destructive boundary looks like. Okay, so here's the diagram that you had in that lesson. So we've got two plates moving towards each other, and crucially, one of them is oceanic crust, one of them is continental crust, and they have different densities. Oceanic crust is more dense. So where they meet is the oceanic crust that is forced downwards. It is subducted. As it subducts into the mantle, the friction here drags the edge of the continental plate downwards, and as we know, that creates an ocean trench. But what it also does is this plate is still trying to come this way as this plate is subducting and dragging the edge of it down, and that creates a buildup of pressure until eventually that pressure will reach a threshold limit and this edge will sort of thrust or ping back upwards to try and lay flat again. And that creates a massive underwater earthquake that pushes the water above it and creates a tsunami wave that ripples out in all directions. If you go on YouTube and just type in the search bar, excuse me, tsunami formation animation or anything like that, it will show you some animations and videos of how that sea floor rebounds and thrusts upwards to create a huge underwater earthquake that creates a tsunami. So job number 1 is to annotate this 4-stage diagram to explain how a tsunami is caused by an underwater earthquake. Now, if we were in school together, we'd be doing this on an A3 sheet like we normally do. Now, there is that sheet attached to this lesson, but if you're not able to print it, and of course I'm imagining very few of you would be able to get it on A3 instead of A4, I've also included this series of diagrams on its own sheet, so you could print them out, just these 4 boxes. If you don't have a printer at all, do your best to make a hand-drawn version. Okay, it's not too bad. You should be all right. See how you go and just take your time. But pause the video here a moment and by whatever means possible, subheading, what caused the Boxing Day tsunami? 4-stage diagram printed out and stuck in or hand-drawn, and then match these annotations to the correct diagram. Okay, so you should have something along these lines. So what's happening here, it's the Indo-Australian plate and the Eurasian plate that are crashing into each other at a destructive boundary, and that causes a lot of friction, as we said. The Indo-Australian plate is the oceanic one, and the Eurasian plate is the continental one in this case study. The plates kind of get stuck and it creates a lot of pressure and bends the end of the continental plate downwards. Eventually that pressure becomes too much, and where it was bent, it sort of thrusts upwards and forwards, and that movement creates a huge underwater earthquake that creates a tsunami wave above it. And that tsunami wave then ripples out in all directions, just like ripples in a pond if you threw a stone in. So I'm going to give you a little bit more context about where it is we're actually talking about. So if I end the show here a minute and come on to Google Earth. So, excuse me, there's us. Okay, so the part of the world that we're talking about for this case study is over here. Okay, so this is the Indian Ocean. Now we can see, even on Google Earth, you can see a boundary running down here. All right, this is the Indo-Australian plate. This is the edge of the Eurasian plate. Okay, they're moving towards each other at a destructive boundary, and that dark line you can see is the ocean trench that forms along the boundary. Now, in living memory, there has never been an underwater earthquake and tsunami in this ocean. They are very common in the Pacific, to the point that near Hawaii, there is actually loads of equipment in the ocean to detect earthquakes in the Pacific Ocean and then send warnings to the west coast of America and to Japan and Southeast Asia, because tsunamis in this ocean are very common, because pretty much all the way around the edge is a destructive boundary. As we know, there was a huge tsunami generated by an underwater earthquake here in 2011 off the east coast of Japan. It's called the Pacific Tsunami Warning Center. And so there's a long history of tsunamis in the Pacific Ocean, but there'd never been one in this area of the world, and it really caught everybody out. So the epicenter, so the point where the shaking of the earthquake reached the surface, was here, just right next to an area called Banda Aceh on the island of Sumatra. So it was a magnitude 9.1 earthquake, one of the most powerful earthquakes ever recorded. At the time, I think it may have even been the first or second most powerful earthquake on record. So in 2004, on the 26th of December, and the waves rippled out in all directions. Now, it affected 13 different countries around the Indian Ocean, and the waves even travelled as far as Somalia over here. It killed nearly 250,000 people, so that would be close to as if you woke up tomorrow and the entire population of Swansea was wiped out. That's the death toll that we're talking about here. All the countries that were affected are LICs, every single one. So the worst hit was Sumatra and Thailand here, quite close to the epicenter. Bangladesh, India, Sri Lanka. The Maldives, these islands here, all of them are very low lying, and the wave completely inundated. That means washed over about 70% of the islands, and they rely heavily on tourism. Most of these countries do. So it took them a long time to recover, because most of the tourist industry, the hotels, etc. were destroyed. It was hours later that it hit Somalia, and yet it still killed some people over here. There's no warning system like there is in the Pacific Ocean. So even though technically they had like half a day's, in inverted commas, warning, there was no warning system, there was no warning message, so people still, there was a death toll all the way over here, even though there was a delay in terms of the time it took the waves to reach that area. So we've got 13 different LICs affected, tourist industry destroyed, obviously lots of roads, docks, hospitals, homes destroyed. I think it was 3 million people or something like that left homeless, maybe even more. The tsunami wave, you're talking, they travel at the speed of a jet plane and are as high as a 6-story building. We're talking about serious impacts here. If you go to the lesson page on Moodle, there's some videos there of the tsunami, what it actually looked like, and of the earthquake as well, because it's caused by an underwater earthquake. So the countries near the epicenter, you'd feel the shaking of the earthquake first. And if there'd been a tsunami in this area before, so people had been educated and understood that, oh, I feel an earthquake, get to higher ground because there's probably a tsunami coming, that would have saved a lot of lives. But like I said, it caught out a lot of people in this area of the world, as there's never been one in living memory. So there's a video of the shaking of the earthquake first, and there's a couple of videos showing the wave washing inland in a couple of news reports and a couple of home videos. So pause the video here a moment. Go into the Moodle page, have a look at those videos to give you a bit of visual context of what it is that we're talking about. Okay, so having looked at Google Earth in a little bit more detail and now got a little bit more of a visual understanding of what the tsunami looks like, this is a map showing all the countries that were impacted. So there's your epicenter, the point where the earthquake happened on the plate boundary. And here are the islands and countries that were worst affected. So Sumatra, Thailand, Bangladesh, the Andaman and Nicobar Islands, the Maldives, Sri Lanka, India, Somalia, and the Seychelles here as well. Here are some key facts about the tsunami. What I'd like you to do here is, if you can, print out this map, then great, and stick it in and describe the location and put in a couple of key facts next to it. I think it might be a little bit too much of an ask to get you to draw this as a sketch map. So if you can't print out the map, don't panic. Just put a subheading, time, date and location of the Boxing Day tsunami, and put down some of this key information. Okay, so we've got the time, the place, the date, the causes. What about the impacts? As I've said, each of the countries that was hit was an LIC. So what I'd like you to do is if you copy and paste this link into your browser, it will take you to the tsunamitrust.org website. And there's a tab in there called the waves. And what it does is it shows you hour by hour how the waves spread and the impact on people in the different countries in terms of death toll, homelessness, etc., the impact on jobs and the economy in each of those countries. And it doesn't tell you much about environmental, so I've put it in here for you. The snag that you might hit is that you need Adobe Flash Player installed on your device to be able to watch this. So if this link doesn't work, just do some general Googling and see if for social you can find out death toll, homeless, anything to do with people. For economic, anything to do with jobs and money and industry. So lots of factories were destroyed, and that means that the supply chain is going to be broken, lots of jobs lost. So what's happening here is you've got the initial primary effects of people were killed, and then you've got secondary effects of, remember, this is a tropical area of the world. So you're going to have lots of homeless people with contaminated water supply and diseases spreading in the hot climate now. Economic, if your tourist industry and all your factories are destroyed, these LICs have got no way of making money. So recovery is going to take an awful lot longer than it would do in an HIC. And there was an awful lot of aid, monetary and humanitarian, given by different countries to try and help the countries that were affected by the tsunami. So your job here is to pause the video a minute, put a subheading, Effects of the Boxing Day Tsunami, try to get at least 5 bullet points under each of these, and you can copy this one as it is. Use this link, or if this doesn't work, do some general Googling research and see what you can find. Okay, so finally, you'll notice an emerging theme here. We're always talking about how LICs or islands or certain countries affected by tectonic hazards, how they could reduce their vulnerability in the future. Now, all of the countries that were hit in this tsunami are LICs. When you're trying to help an LIC, whatever you're doing needs to be affordable. It needs to be simple, easy to repair technology because people don't have the skill set or the education to manage anything more high tech. It needs to be small scale, usually, directed at the people that need it most and the villages that need it most. So you could install a seismograph. Now we're going to look at this in more detail in a lesson called the 3 Ps, Predict, Protect, Prepare. You might remember a little bit about it from year 9. A seismograph, seismic activity, is ground shaking, earthquakes. Okay, so what a seismograph does is it monitors ground shaking. It's a very simple piece of technology that is essentially a needle with ink on the end, hovering over the top of a big barrel that looks like a giant loo roll. It's a massive roll of paper. And the roll of paper passes underneath the needle. And when the ground shakes, the needle shakes, and that makes like a shaky line on the paper. If you Google seismograph, you'll see a visual, obviously, of what I'm trying to describe. So this is simple, cheap, and what it will do is help villagers to predict, to roughly guess when an earthquake might happen. The more shaking is recorded on that paper, it indicates that there's maybe some small tremors going on, and that can be a precursor, that can be a warning sign that a larger earthquake is about to happen. And if you can predict when it might happen, that means you can get out the way. You can evacuate, and that's going to save lives. You could build homes from wood or bamboo instead of concrete. Now, this might sound a little bit silly because concrete is super strong, right? What you may have seen a little bit when you were researching your Haiti case study is that in LICs, buildings tend to get thrown up, unregulated. They don't have all the building regulations that are reinforced and planning permission and stuff like they do in this country. So homes being made out of concrete, what they tend to do is it's poured concrete, literally just concrete blocks with no reinforcement in it. For a concrete home to be stable, it should be reinforced with loads and loads of steel rods, but steel rods are expensive. So that's often not done in LICs. And when the ground shakes in an earthquake, what happens with concrete is it's very, very rigid. So as soon as the ground shakes, the walls collapse in on each other, and the floors and ceilings is called pancaking. They sort of fall down on each other like a stack of pancakes. So concrete, it can be very, very cheap, but when it's done cheaply, it's very rigid and very vulnerable to collapse during an earthquake. Wood and bamboo are far more flexible. They are natural materials, so it's environmentally sustainable. Bamboo is one of the fastest growing materials in the natural world, so it's very cheap and accessible in LICs, and it's far more flexible, so it will actually help to absorb a little bit of the shaking and be less likely to collapse. You could put in battery-powered radios. Now, the key thing here is it's battery-powered, not powered by electricity. So you don't need complicated infrastructure, electricity pylons, electricity wires, things that people in LIC villages and rural isolated villages often don't have. You can actually have a battery that is recharged by what's called a dynamo. So on the side of the radio, there'll be a little lever, and you turn that lever, and the movement energy, the kinetic energy, charges the battery with electrical energy. It's very clever. Very simple, affordable. You don't need electrical infrastructure. And what that radio could be used for is receiving a warning. There is now lots of detection systems in the Indian Ocean, and when that system detects any ground shaking, it can send a warning to simple technology like these battery-powered radios, and that means that people have time to evacuate, and that's going to save lives. But it's simple, affordable technology, easy to use, easy to fix, easy to make. Create hazard maps for high-risk areas. We do this for a lot of different hazards, everything from flooding to volcanic eruptions, tsunamis, earthquakes, etc. What you do is basically look at the relief. So areas that are more mountainous, you're probably going to get landslides in an earthquake. Areas that are really flat or near the coast, you're going to get more affected by a tsunami. And you create a hazard map that is color coded. The highest risk areas are red and orange. And what you do is you just don't build in the high risk areas. So hazard mapping, it removes the hazard altogether. An eruption, an earthquake or a tsunami is only a hazard if people are in the way. So just don't live in the way of these hazards. The problem with hazard mapping, number one, when you identify a high risk area and say, right, don't build there, it's got to be regulated and it's got to be monitored. And that often doesn't happen in LICs. People build on marginal land that is on the margins, on the edge of what is survivable, because it's cheap. No one's going to push you off because nobody else wants it. So that's where you get your favelas, your slums, your shanty towns, your low-income communities setting up home on steep slopes, on floodplains, in the shadow of a volcano, because it's cheap, easily accessible land that nobody else wants. So problem number one, it's difficult to monitor. Problem number two, the safe areas, everyone wants to build there, everyone wants to live there. So it's going to become very expensive and very overcrowded and densely populated very quickly. And we know that dense population is a factor that increases vulnerability. So this idea can backfire sometimes. So pause the video here a moment and basically put this subheading and make this table into your books. You're welcome to summarize these points a little bit further if you can, but I've already tried to cut them down as much as possible. Okie dokie, and that brings us to the end of lesson 7. Well done. We've got one more hazard to go. We're going to look at a volcanic eruption next lesson, and then after that we're going to look at ways in which people can further reduce the risk from tectonic events. So the 3 Ps that I've been talking about: predict, protect and prepare. So well done for today. Any questions, drop me an email as usual. Otherwise I'll see you soon for lesson 8.